Here's something strange when you actually stop to think about it. Melt an ice cube and you get water. Freeze that water and you get ice again, back and forth, forever. But crack an egg into a hot pan and it goes from clear and runny to white and solid. And there is absolutely no way back. You cannot uncook it. No amount of cooling, freezing, or waiting will turn it clear again. So what makes cooking an egg so permanent when melting ice is so reversible? The answer is one of the most important ideas in all of cooking, and it's happening at the level of individual molecules. Let's look at what a raw egg white actually is. It's mostly water, around 90%, with proteins dissolved in it. And here's the key thing about those proteins. Each one is a long chain, but it doesn't float around as a loose string. It's folded up tightly and specifically into a compact little ball. Think of a long piece of string scrunched into a neat, tangled knot. Each protein has its own precise folded shape, held together by weak internal bonds. And because they're all folded up compactly and kept apart from each other, light passes right through. Which is why a raw egg white is clear and liquid. Those neatly folded separated proteins are the before state. Everything about cooking an egg is the story of what happens to that folding. So hold on to the picture. Folded proteins floating separately in water. Now, add heat. Heat is energy, and energy makes those protein molecules vibrate and jostle harder and harder. And here's what happens. Those weak internal bonds, the ones holding each protein folded into its neat little ball, start to break. The proteins lose their careful folded shape and unravel into loose, open strands. This unraveling has a name, denaturation. It just means a protein losing its folded structure. Plain and simple, the knot comes undone. And notice, nothing's been destroyed yet. The protein chains are all still there, intact. They've just gone from tidy folded balls to loose, floppy strings, all now exposed and tangling out into the water. That single change, folded to unfolded, is the doorway. Because once these proteins are unraveled, and their sticky inner parts are exposed, they're about to do something they could never do while folded up. Here's where uncookable comes from. Those unraveled protein strands are now exposed and they start bonding. They bond not back into their own original shape, but to each other. Neighboring strands link up, forming brand new bonds between completely different protein molecules. And they don't just link once. They tangle and bond into a vast interconnected mesh, a three-dimensional net that spreads through the whole egg white. This is called coagulation, and that mesh is what traps the water, turning a runny liquid into a firm, solid, opaque white. The light can no longer pass straight through, so it turns from clear to white. Now, here's the crucial part. To uncook the egg, you wouldn't just need to cool it down. You'd need to break every one of those new bonds, and then somehow refold each individual protein back into its own exact original shape perfectly without them retangling. And there's simply no everyday process that does that. The proteins have joined into a new structure that heat built and cooling can't undo. So why is melting ice so different? This is the satisfying part. When ice melts, the water molecules themselves don't change at all. They just loosen their arrangement from a rigid crystal to a free-flowing liquid. Nothing is broken and rebuilt. So you can freeze and melt back and forth endlessly because you're only rearranging the same molecules, not transforming them. The egg is a completely different kind of change. Cooking didn't just rearrange the proteins. It unraveled them and bonded them into an entirely new structure that wasn't there before. And that's the real dividing line in chemistry. Some changes just rearrange things and you can reverse them. Others build genuinely new structures, and those are one-way streets. Melting ice is a rearrangement. Cooking an egg is construction. And you can't unbuild it by cooling it down any more than you could unbake a cake or unburn a log. The egg didn't just get hot, it became something new. And here's the bigger idea. The reason this channel exists. We tend to think cooking is just heating food up. But heat isn't only making things hotter, sometimes it's rebuilding them at the molecular level into something that didn't exist before. That's the difference between a physical change you can undo and a chemical one you can't. And once you see it in the egg, you start seeing it everywhere in your kitchen. Bread crust, seared steak, caramel, a set custard. All of them are proteins or sugars being permanently rebuilt, not just warmed. The next time an egg goes from clear to white in your pan, you'll know you're not just cooking it. you're watching thousands of tiny knots tie themselves into something new. Permanently. If you want more kitchen chemistry taken apart like this, subscribe. I'll see you in the next one.